1.48 from OpenStax PreCalculus. Here we're solving an absolute value inequality. These are not easy problems to do. There's a lot of steps to them. There's several ways you can do them. The easiest way is the way that your book presents, which is kind of nice. And what it tells you to do is solving absolute value inequalities is hard, but solving absolute value equalities isn't so bad. You've been doing a lot of that in this chapter. So maybe by the time you get down to this part of this, I guess, section, you know how to solve this. And yes, I recognize this is not what's asked, but that's okay. Solve this thing. How do you solve an absolute value equality? Well, you first isolate the absolute value. That's already done. How convenient. And then think about what this means. How could you make this statement true? Well, it would be true if what was inside the absolute value symbol equaled 6, if this were a 6 right here. But it would also be true if what's inside the absolute value equals negative 6. And now what I have are two equations, neither of which have an absolute value symbol. So I can solve them relatively easy. And I get here, 4 and negative 8. This is not the answer to the question. The answer to the question will have something to do with this, but it's not just 4 and negative 8. I see a lot of students try to say, oh yeah, okay, so it must be the numbers between 4 and negative 8. Be careful. Don't try to cheat the system. Don't try to find shortcuts for problems like this. Problems can be written in a way where your intuition would be off. Really, the best way to figure these out is to create a sign line. And I know that's kind of annoying. I know people don't really like doing that. But it's the best way to go when you're solving a problem like this. And so what I mean by a sign line is take these two solutions and write them on a number line. These two solutions will divide my number line up into 3 different regions. There's one of them, there's the second one, there's the third one. And the easiest way to test where your solutions are just to test numbers from each of these 3 regions. So pick any number from region 1. Maybe I'll say test here. So any number that's less than negative 8, I don't know, negative 10 maybe. Totally up to you what you choose. Take negative 10 and plug it into this original equation to see if you get a true statement or a false statement. Negative 10 plus 2 is negative 8. And sorry, not into this one, into this one right here, into the problem you're trying to solve. Take negative 10 and plug it into here. Negative 10 plus 2 is negative 8, and the absolute value of negative 8 is positive 8. Let's write that instead of talking so much. Less than or equal to 6, question mark? No, it's not. The reason it's not is because this is negative 8, and the absolute value of negative 8 is positive 8, and positive 8 is not less than or equal to 6. What I'm saying is that negative 10 is not in my solution set, and therefore no numbers in region 1 are in my solution set. You can now test region 2 in the same way. Pick any number you want in region 2, any number between negative 8 and 4. I prefer to pick 0, you don't have to. And take that and plug it in here. The absolute value of 0 plus 2. The question is that less than or equal to 6? It is. And the reason why is the absolute value of 0 plus 2 is just the absolute value of 2, which is 2, and 2 is less than or equal to 6. Yup. Not only is 0 in my solution set, that tells me that all the numbers in between negative 8 and 4, all the numbers in region 2, are in my solution set. What about region 3? Do the same thing. Test a number in region 3, whatever the hell you want. I'm going to pick 5. The absolute value of 5 plus 2? Is that less than or equal to 6? Question mark? No. Because 5 plus 2 is 7, and the absolute value of 7 is 7, and 7 is not less than or equal to 6. 7 is greater than 6. So I don't get any solutions over here. So the only solutions I get are region 2. So the answer to my question is all the numbers in region 2. The only thing you have to be careful about is whether or not you should include the endpoints, negative 8 and 4. In this case, I do want to include the endpoints because I don't just want x plus 2 to be less than 6. I want x plus 2 to be less than or equal to 6. And I found that when x equals 4 and negative 8, in other words, at these endpoints, x plus 2 is exactly equal to 6. So I do want to include those because equal to 6 satisfies this criteria. So the answer to this question would be all of the numbers. It's a strange looking bracket. Still a little strange, but it's good enough. All of the numbers between negative 8 and 4, including those two endpoints.